The midpoint formula is not that useful, to say the least. It only has one real use, and that's just to find the midpoint. If you want to find a point that's a quarter of the way, well, you could use the midpoint formula for that. You take the midpoint formula twice, the midpoint of the midpoint. But if you want to find something that's a seventh of the way there, or 19/38ths of the way there, you're not going to be able to do that with the midpoint formula. And also, there are just so many ways of doing it. It doesn't really make much sense to learn it at all. Actually, I don't recommend learning it at all. But let's go ahead and learn the method they teach in the book, and then I'll show you a different method. And also, there are other methods too. When we learn about slopes in the future, you can use that to find the midpoint. But let's start talking about their method first. Their method is based on averages. So let's say I have 0, 2, and 100 on a just one-dimensional number line. If I wanted to find the midpoint of this one-dimensional line, I can just look. Well, it's such trivial numbers that we don't really need to, but we can take an average of it. 100 plus 0 divided by 2 is equal to 50. It's like calculating test scores, like an average of a test. Like your average grade is probably the simplest way to think about it. Let's suppose I got an 80 and a 90. I can simply add 80 plus 90 divided by 2, and the midpoint of that is 85. So if I wanted to write a general form for finding an average between two numbers, I could write it like this: x1 plus x2 divided by 2. So this is a general form for an average. So now let's take this and apply it to 2 dimensions. So if I want to find the midpoint between 2 points in 2-dimensional space, I think it'll be easiest for me to explain with a rectangle. So here's my rectangle, and here's the center of my rectangle. Now one property of a rectangle is if you go and divide it in 2 like that, this exact middle of the rectangle will be the middle of this line, intersecting it in a to 2 triangles. So this right here, so the middle of the triangle is the midpoint of this line from here to here. But one thing we know about the center of a rectangle is that we can drop this down right here and know that this point right here is just half of whatever this side would be. So you know what that means? That means this is just an average. And we can do the same thing through the side. So now you can see we know that if we drop the center of a rectangle down, it just divides this side into 2, which means that if this was a length, it would just be half the length. So that means we can use our averages to find out what that number would be if it was on a coordinate plane. So that means if I wanted to find the x value of this point right here, it would just be x1 plus x2 divided by 2. And if I wanted to find the y coordinate of this midpoint, that means it would be y1 plus y2 divided by 2. And that is the midpoint formula. It's written like this, just x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Because again, this is the midpoint. We know this because this is a rectangle, and this is the midpoint of it. And if we drop these down, it just cuts these sides in 2. So if we know what the half is, we can figure out what it is. So let's just make up some points. Let's make up and just use it and show how it works. Let's say that this point is 2, 0, and this point up here is 4, 6. So in order to use it, just go to my x1, which is 2, plus my x2, which is 4, divided by 2, and for my y's, my first y is 0, my second y is 6, divided by 2, and then I just do that math and I get 3, 3. So this midpoint is 3, 3. And if I wasn't sure and I wanted to check, what we could do is find the distance between these 2 points. So we could find the distance between the first point and the midpoint, and then we could find the distance between the midpoint and the second point. And if this is a midpoint, both of these distances, so this distance and this distance, would be equal. But I'm not going to do that. You can check it if you want. I'm going to move on to the second method I was talking about. And it goes through a slightly similar idea. So let's draw the 0 to 100 again. So the first time we just took the average. What we could do is just do 100 minus 0, which is 100. So this is the difference between the beginning and the end. And then what we can do to find the exact middle is just divide it by 2, and that's equal to 50. So we found it like that. And we can do, so let's do 80 and 90 again. Or 80, 90. So we could find the difference. 90 minus 80, which is equal to 10. So the difference between these is 10, so we want to find exactly half. So we multiply by half or divide by 2, it's the same thing, which is equal to 5. Now I got this 5, now I add that to the lower one. Or I could subtract it from the bigger one, but I'm just going to do the addition. So 80 plus 5 is equal to 85. And that's the same thing we got up here when we just did the average. So look, 80 plus 90 divided by 2 is equal to 85. So we could write this in the general form. So let's write this in a general form. So that means what we've done is we've found the difference. We've taken the bigger number, subtracted the smaller number from it. Then we multiplied it by 1/2, or divided by, multiplying by 1/2 and dividing by 1/2 is the same thing. So we multiplied it by 1/2, and then we added it to the smaller number. So that's the general form of what we've done. And this might seem a little bit more complicated, and you might wonder why I would pick this. But you'll see in a moment why it has more useful applications than the other one. So this is the general form. So if we draw that rectangle again, so let's draw a rectangle again. Here's the line that cuts it in two, and we proved that, and we know that this is the midpoint between there. So if we want to find the coordinates for this point, so instead of using the average, we can use this instead. So basically what this formula is saying is we're going to subtract this point from this point. So we know how long this is. Then we're going to divide it in 2, and then we're going to add that to this point. So that'll give us this x right here. So if you follow me. So that means we can write this down here. 1/2 x2 minus x1 plus x1. So this is going to figure out the x coordinate, and then we're going to do the same thing for the y coordinate. So 1/2 y2 minus y1 plus y1. But now say I don't want to know what the midpoint is. Let's say I want to know what 1/10 of it is. Let's say I want to know what 1/10 along this line is instead of 1/2. The midpoint formula would not be able to tell me that because it's an average. So what I can do for this one instead replace 1/2 with 1/10, because I'd be finding the difference here, and then instead of 1/2, I'd want to know the point at 1/10. So 1/10 up here and 1/10 over here. So I would do, instead of 1/2, I would write 1 over 10. And in here, I would write 1 over 10. But there's a more convenient way of writing that, because instead I want my formula to be flexible. I don't want to have a different formula for 1/10, 1/8, 1/2, 1/5. So what I can do is, instead of writing a number here, or let's just use this one, instead of writing a number here, I can just replace this with a variable. Let me just write d instead. D for distance. So a distance that is a ratio. So a distance of let's see, a 1/2 way along, or 3/4, or 7/8. So let me scroll over. So that means the formula would be the distance, whatever distance I want. And the distance has to be a ratio. It has to be 1/2 or 7/8, or it can even be a percent. I can say, how far is it 50% along the line? 50% is the same thing as 1/2. So x2 minus x1 plus x1 and then for the y coordinates, it's the same thing but with y's. So whatever the distance, y2 minus y1 plus y1. I don't know what just happened. Oh, there we go. Man, what the hell happened to that? Okay. Well, there you go. This is just an alternative formula that it will give you different things. It can give you the midpoint formula if you want. It will give you the midpoint if you want. If you want the midpoint, you just put d in as 1/2. If you want 1/8 of the way, you put in 1/8. And so on and so on. So I feel that this formula has slightly more applications, and later on you'll be using the you'll be using the slope, which is very easy. You just don't need to remember anything. So that's why I really feel that the midpoint formula is it's a little bit self-explanatory, and it's not really worth remembering. If you end up memorizing it, you'll most likely forget it, and then when you forget it, you'll have no idea how to get the formula. So it's best just to work it out rather than memorizing it.